everybody, today I'm going to show you two examples of power dissipated by a resistor. Our first example says a 49 kilo ohm resistor has a current of 4.8 milliamps going through it. We want to find the power dissipated by the resistor and write our answer in milliwatts. We're going to use the formula P equals I squared R. In our example, I is 4.8 milliamps and R is 49 kilo ohms. So our power is 4.8 milliamps squared times 49 kilo ohms. We want to adjust the milliamps and kilo ohms before we go farther in the problem. So remember that milli is a prefix for 1 over 1,000 that we often write as 10 to the negative 3. Kilo is a prefix for 1,000 that we write as 10 cubed. We like to write things in a base of 10. We're going to go back and rewrite our equation as 4.8 times 10 to the negative 3 amps squared times 49 times 10 to the third ohms. If you square 4.8, you get 23.04. When you square 10 to the negative 3, you get 10 to the negative 6. I want you to think negative 3 times 2 is negative 6. And then when I square a, I just get a squared. We'll use 49 times 10 cubed in the next step. Now I'm just going to multiply the number parts. So the 23.04 times the 49 gives me 1,128.96. The 10 to the negative 6 and the 10 to the power 3, you add the exponents. So negative 6 plus 3 gives me a negative 3. Then I collected my two units, a squared, and instead of writing the ohm, I wrote V over A. We want our final solution in milliwatts. When we reduce the A's, canceling one of the A's from the A squared with the A from V over A, we end up with just AV, which is a watt. Remembering that 10 to the negative 3 is our prefix for milli, lets us incorporate the 10 to the negative 3 and the watts to give us our final solution of 1,128.96 milliwatts. Our second example says another resistor has a voltage drop of negative 19 volts. The resistance of the resistor is 21 kilo ohms. We want to find the power dissipated by the resistor, and again we're going to write the answer in milliwatts. This time our formula is P is V squared over R, which means we have P is negative 19 V squared over 21 kilo ohms. We'll change 21 kilo ohms into 21 times 10 cubed ohms. Then I'll square the numerator. Negative 19 squared becomes 361 and V becomes V squared. Next I'll gather the information into three parts. I'll put 361 over 21. I'll put 1 over 10 cubed to show that 10 cubed was in the denominator, and then I'll put the units together, which is V squared over ohms. 361 over 21 I'm going to write as 17.19. 1 over 10 cubed is 10 to the negative 3, thinking an exponent in the denominator is really a negative exponent. Then instead of V squared over the ohms, I'm going to write V squared over V over A. Let's take a look at the units a little closer. When I divide by a fraction, I multiply by the reciprocal. That means I have V squared times A over V. This lets me cancel one of the V's and just come out with VA, which we know is a watt. 10 to the negative 3 standing for 1 over 1,000, or a milli, which tells us our final solution is 17.19 milliwatts.